Hi friends, I thought I'd go over this homework with you. A little bit challenging, the second one to say the least, but theoretically you could also do it, but it was just way over the top for me in terms of time it would really take to do it. First one, pretty straightforward. What you have here is a loose light cube. You get the volume side cubed, and then you got the mass, so 4.9 divided by the cube of 142.5 grams. You can do that one, I'm assuming. However, here's the one which was more of a challenge, which was if I gave you this table here, which actually will transpose over here, of the Earth, and with the crust mantle, the outer and inner core, and some of the information was given here. But it really comes down to two things. If you know the formula for density, which you do, you showed me that, density equals mass divided by volume, and if you know the volume of a sphere, you can actually figure these things out, but it's a pain in the butt. In any case, first one, the average density of the Earth. Well, that's the one you should all be able to do because in the article, or at least in the homework, they did say, oh, here is the radius of the Earth. And keep in mind that you kind of think of the Earth as these kind of like concentric circles of sorts, at least a structure with the mantle, which is the biggest part, the crust, and then the inner and outer cores here. And so the first one should have been pretty straightforward. Just again, the volume is 4/3 pi r cubed, and in fact, I think I did it here somewhere for you guys. Not there. It's actually here. So there's the radius. You get the volume, which you can crank it out, and if you have the mass, which was given you, you just crank it right out, as I said. And I did it both using grams per cubic centimeter, and I also did it in kilograms per cubic meter, both ways in which it's commonly done. But you notice the relationship here, it's off by about 1,000, at least in terms of decimal points, the two. Something nice to know. For example, the density of water is 1 gram per cubic meter. The density of water is also 1,000 kilograms per cubic meter. A nice thing to keep a handle on. So the first one shouldn't have been much of an issue. However, the next ones were more of a challenge. And so going back to my little pictures here, think of the Earth, of course, even though it's not a perfect sphere, it's an oblate spheroid. We're making that assumption so we can use the volume equals 4/3 pi r cubed. And as I go down a little bit farther here, yeah, I'll stop right here. So the question is, what percent of the Earth's mass is located in the mantle? So in order to figure that out, what's given? Well, we do know the density of the mantle. So therefore, if we can figure out the volume, we can then backtrack and figure out the mass. And then if we know the mass of the Earth completely, we can do a pure proportion to get percentage kind of thing. So therefore, the problem is, what is the volume of the mantle? Well, if you consider that the Earth is made up of these little balls within a ball within a ball kind of thing, that makes your life a little easier. So let's assume that the red is the mantle, and here's the inner and outer core. I should say outer and inner core. And so think of them kind of like little circles within, or I should say spheres within spheres. And so if we can figure out the volume of this ball here and subtract it from the volume of this ball here, we should get the mantle, which basically, if you think about it, is we're looking for the donut there, just the donut part. And so we can figure out the radius of these different spheres or circles. Actually, they're spheres, but well, we need to get the radius. We can get that from looking at the depth that was given. If you go back to that original table, it tells you how far down they go. And then from that, you can actually determine the radius. And so what I figured out was that the depth, if I looked at it in terms of the thickness, which is kind of like the radius down, we can then figure out the volumes of these things. And so the radius of this mantle here is 6,350 kilometers, and the radius of the inner and outer core together would be this 3,480. So once I have that, I can do a little quick arithmetic. All I have to do essentially is figure out the volume of the mantle, outer core, and inner core, which is the big red circle, and then the volume of the outer and inner core, which in my little context up here is this little brownisher kind of circle there. Once I have that, I subtract one from the other, and I have the volume of the mantle. And then I just used my density formula. Though I have density, I have volume, so I want mass. And so now it's just mass equals volume times density. If I crank that out, I get this value here for the mass of the mantle. And then just a quick kind of percentage problem. Here's the mass of the mantle, here's the mass of the Earth, and it sure enough turns out to be 67.54%. In fact, if you Google what is the percent mass of the mantle, you'll find it's 67%. Okay, then the last question was the average density of the core. Okay, well, it comes back to the same type of question. Again, that the average density of the core. Well, how do we figure out the average density of the core? If I go back to my original information here, we don't have the density. That's what we're looking for. However, if we can figure out the mass of the core, if we can figure out the mass of the core, we have the volumes, and we can then backtrack. And essentially, I did the same type of information again. That I used some of the information from what I did before. So the average density of the core. Well, if we figure out the radius, again, we can get, which we have all the information. We can then figure out what the volume is. And again, it's kind of a subtraction thing again. But this time, we're only subtracting the volume of the mantle and the outer core and the inner core from this part here. So basically, it's back to our little circles here. It's getting dizzy yet. The volume of the mantle minus the cores, because it's the cores we're asking for here. And if I crank down a little bit farther here, once we have that figured out, we can then do some of the other math here. And really what we have to figure out is the crust. Why the crust? Because we need to get the mass, and we have the mass of the entire Earth. We have the mass of the mantle. We have the mass of but we don't have that information. From there, we can actually then backtrack. I know I'm kind of rambling on here because it's early in the morning, and that's the problem, but it's doable, essentially. But the basic concept, and you can slow this down, look at it. I don't know why you'd want to, but the basic concept still comes down to, okay, we have a sphere, and if we know the volume and the mass, we can get density. If we know the density and volume, we get mass, and if we know vice versa, it's just kind of a chug and plug, but on steroids, essentially. So I would never, so I apologize for such a long kind of question, but I think Margaret was nice enough to send out an email, and I shot out an email too saying, like, just stop it, the first one. So enjoy your day.